Today I'm going over the notes for 6.3. It's solving square root equations, and this is the slightly harder version. The steps are exactly the same steps I went over yesterday to solve a square root. You isolate the radical, square each side to eliminate the radical, solve the quadratic equation, and check for extraneous solutions. So you could have one solution, two solutions, or no solution.
Wait, so why you cancel it up? Why you say skip on that one?
I was just going to skip that one because there's 4 examples and there's really nothing special about that one. No real reason. So the first one, we're following the same steps as yesterday. Isolate the radical. It's already isolated. On the right, it's just the square root. So then the next step is to square both sides to cancel out the radical. Square root squared cancel. So x squared equals x plus 12. All right, so now I want to get everything to one side because now I have a quadratic. This is what we did not have yesterday. Yesterday we just had simple linear problems. No x squared value. Now we have an x squared value. So to solve it, we have to solve by factoring. Technically, you could solve by quadratic formula if you wanted to, but that's a lot of steps for something this basic. So we're just going to solve by factoring. So I'm going to subtract x and subtract 12. Move it all to the left. So on the right side it cancels. On the left side now I have x squared minus x minus 12. And it's equal to 0. So I am factoring, but this is a really simple factoring problem. My a value is 1, so I know I don't have to worry about dividing by a. And I'm going to multiply to negative 12, and I'm going to add to negative 1. So if I pick 3 times 4 as my factors, and then I make the 4 the negative one, then 3 minus 4 is negative 1. Those would work. So I set up my factors equal to 0. Split up the x's. X plus 3, x minus 4. So I factored it, but I need solutions. So to get solutions, I set each factor equal to 0. So x plus 3 equals 0. So x equals negative 3. X minus 4 equal to 0. So x equals positive 4. Those are my 2 solutions. I don't know if they are both solutions, or if only one of them is, or maybe neither one of them will work and it's no solution. I have to check both of them to look for extraneous solutions. So I need to check. I get the original problem, the one that is printed on the paper. And for every x, I'm going to plug in a negative 3. So I have negative 3 equals the square root of negative 3 plus 12. So negative 3 equals the square root of 9. Before, when we were solving quadratics, we would say that's true. But right now, we're saying that's not true because this is called the principal square root. So this is false. This is not true, which is tricky. So this is going to be an extraneous solution. Negative 3 is extraneous. I'm going to abbreviate extraneous with an EXT. Because the principal square root is just taking the positive version of the square root. Square root of 9 is 3. Square root of 4 is 2. But when you're solving an equation, like what we were doing with quadratics, then you do the positive and the negative because you're solving. This is checking the principal square root. We're just checking this value of the square root. So we're only looking at positives when we're checking. So that's why this is false. Even though in the last unit, when we were solving, we would have said that's true. Does that make sense? maybe?
How is it false? Like, what is?
Because we're only looking at the positive version. It's something called the principal square root.
So if it's negative, then that means it can't work. Is that what you're saying?
Yes, that is what I'm saying. The square root's not going to equal negative. Because this is like back whenever you first learned about the square root. I don't know at what age that was, but we'll say 6th grade. I don't really know. Where you were given square root of 4, you would automatically say 2. You wouldn't have said 2 and negative 2. You just said 2, right? That's what we're looking at. That's the principal square root. The principal square root is the positive version only. So this makes this a false statement. So that is not a solution. It's an extraneous solution. And then we have to check the other one also. We need to check 4. So 4 equals the square root of 4 plus 12. So 4 equals the square root of 16. Yeah, that's true. 4 equals 4. So we have one solution here. X equals 4. And really that sums up what I'm showing you today. I'm going to do 2 more examples, but it's that you have quadratics now. You're going to have to factor. They're going to need some pretty basic factoring, like this one. It didn't really take a lot to go through the factoring, but this is the difference between the hard problems today versus the simple ones yesterday, where you only ended up with one possible solution to check. Now you have 2 because we're solving the quadratic with factoring. All right, so I'm going to look at this one. So I'm going through the same steps. Get the quadratic part, the square root part. It's not quadratic, I'm sorry. To get the square root part by itself, the radical needs to be by itself. To do that, I'm going to subtract to the 7. Oh, my pen's way off today. There we go. So n minus 7 equals the square root of negative 3n plus 19. So I have n minus 7. I'm going to go ahead and put that in parentheses. Group it together, because that's a binomial and I know it's attached now. Now I want to get rid of the square root. To do that, I'm going to square it. If I square one side, I have to square the other side. Square root, squared, cancel. So on the right, I have negative 3n plus 19. And on the left, I have n minus 7 squared. All right, so I need to multiply that out. So I'll do that right over here. So I have n minus 7 times n minus 7. And this is the safe way of multiplying it out, is times itself, do the double distribute. N times n is n squared. N times negative 7 is negative 7n. Negative 7 times n is negative 7n. And then negative 7 times negative 7 is positive 49. You're going to have like terms in the middle every time. So n squared minus 14n plus 49. Now if you notice, whenever you square a binomial, and it's only whenever it's something times itself, n minus 7 times n minus 7. If those were 2 different values, this doesn't work the same. But if you're squaring a binomial, the shortcut method of that, which I know I've told you all this before, but we've been working with quadratics a lot more, and it's probably going to be a little simpler to understand at this point. So I have n minus 7 squared. I know I'm going to square the first part, so n squared. Double for the middle term. I know I need 3 terms if I'm squaring a binomial. I know the result is going to be 3 pieces. The middle one is going to double it. So I have negative 7, so negative 14, and I need the n with it. And then the last piece is square the negative 7. Negative 7 times negative 7 is positive 49. So the pattern for squaring a binomial is square, double, square. Or you can go over to the side and calculate it out. There's nothing wrong with that. All right, moving on to the next step. I need to solve. To solve the quadratic, I need everything on one side. I want to keep the n squared positive, so I'm going to move everything to the left. So I'm going to add 3n and subtract 19. So I have 0 on the right, n squared minus 11n plus 30. N squared minus 11n plus 30 equals to 0. So I'm going to factor. I need to multiply to 30 and add to negative 11. Now multiplying to a positive and adding to a negative, I know both of the values have to be negative. I'm going to multiply to 30 and add to 11. 5 times 6 is 30. So negative 5 times negative 6 is 30. And negative 5 minus 6 is negative 11. So those are the factors. Split up the x's. Negative 5, negative 6. Since the a value was 1, whatever's in front of n squared, that's 1. When I divide by 1, it doesn't change anything. So we're done factoring. But then I need to solve. I need solutions. So I take each one, set equal to 0. X minus 5 equal to 0. So x equals 5. X minus 6 equal to 0. So x equals 6. So that's my two possible solutions. But I have to check them. That maybe they both check. Maybe they're both true solutions. Maybe one of them is extraneous, or maybe they're both extraneous. I have to check. So to check, I use the original problem. I'm checking here with this. So check. I'm going to check 5. So 5 equals 7 plus the square root of negative 3 times 5 plus 19. All right, so I'm checking that. I start with the radical. Negative 3 times 5, that's negative 15. Negative 15 plus 19, that's 4. So I put that together. This makes a 4, so that's the square root of 4. Bring down the rest of that. Square root of 4 is 2. 5 equals 7 plus 2. No, 5 does not equal 7 plus 2. That's not true. Because I would say 5 equals 9. 5 does not equal 9. So 5 is not a solution. It is extraneous. Alright, so I checked that one. I need to check the other one. X equals 6. So again, I'm going back to the original problem so I don't make a mistake. If I made a mistake in my factoring or copied something down wrong, I would be checking it in the wrong spot. So I'm going to check the original one. 6 equals 7 plus the square root of negative 3 times 6 plus 19. Negative 3 times 6 is negative 18. Negative 18 plus 19 is 1, so that's just the square root of 1. 6 equals 7 plus the square root of 1. Well, the square root of 1 is 1. 7 plus 1 is 8. And 6 does not equal 8. So since 6 does not equal 8, that means it is extraneous. So I'm going to cross it off. Label it as extraneous. Since both of my solutions are extraneous, that means there is no solution. So, no solution. is the answer to that one. Since they both failed the check, then there is no solution. And then I have one more example for you today. Step 1 is to isolate the square root. It's already all isolated. There's nothing over there, just the radical. So then step 2 is to get rid of it. So square it. If I square one side, I have to square the other side. Square root squared cancel. 6n minus 29 equals n minus 4 squared. So again, I could take n minus 4 times n minus 4 over to the side, or I could follow the pattern that you follow when you square a binomial. Square the first part. I know it's going to be 3 pieces. Square the first part, so n squared. Double for the middle one. Negative 4 doubled is negative 8, and it needs an n. Square the last part is negative 4 squared is positive 16. If that doesn't make sense to you, it's perfectly fine to take it to the side. Take this over here to the side and do n minus 4 times n minus 4 and multiply the whole thing out. When you do that, you'll end up with this. Whichever way makes sense to you, that's the way you should do it. Okay, and then I need to solve the quadratic. So I need to factor it. To factor it, I need everything together. So I need to subtract the 6n and add the 29. So 0 equals n squared minus 14n. Is that plus 45? Plus 45. And then factoring, multiply to 45 and add to negative 14. All right, so 9 times 5 is 45. If I make them...
How do you still have 0 equals n with 2 over top if you already subtracted everything? Oh no, you got that from negative 8 now. Like how did you get, you got 0 equals n2?
Yeah, n squared.
So how did you get that?
Oh, I just brought down the n squared. I didn't change that part of it.
Oh, okay.
I just moved over the 2 pieces that were by themselves over there on the left. So then I need to multiply to 45, add to negative 14. 9 times 5 is 45, but to get to a negative 14, I have to make them both negative. So negative 9 and negative 5. Negative 9 minus 5 is negative 14. So those factors do work. So x minus 9, x minus 5 equals to 0. When I solve those, I get x equals 9 and x equals 5. So these are my 2 possible solutions, but I need to check them to make sure that they both work or to see if one or both are extraneous. Alright, so I'm going to check it. I have the square root of 6 times, I'll check the 9. 9 minus 29 equals 9 minus 4. Alright, so 6 times 9, that's 54. 54 minus 29 is what? 25? Yeah. 54 minus, yeah, that's 25. So I'm at the square root of 25 equals 9 minus 4, that's 5. Yes, square root of 25 is 5. 5 equals 5. So x equals 9 works. That is a solution. And then I still have to check x equals 5. So the square root of 6 times 5 minus 29 equals 5 minus 4. Okay, 6 times 5 is 30. 30 minus 29 is 1. So I'm at the square root of 1 equals 5 minus 4. That's 1. Square root of 1 is 1. 1 equals 1. That works also. So x equals 5 is a solution. It checks. So they are both my solutions. I have two solutions to that one. So I showed you a situation where you have two solutions, no solution, and one solution. The first one only had one solution. And remember, we're only looking at the principal square root, meaning the positive version of the square root.